Okay, folks, here we go. Last topic already. Wow, that's quick, yeah. Last topic is solving joint and combined variation problems. So when you hear joint variation, what that means is there's more than one variable, and typically when you hear joint, it means it's still a direct variation, but there's just more than one variable. So here z is varying directly or jointly as x and y. You could also say directly because they're both being varied directly. Yeah, because why? Because they're up top, right? They're multiplying. They're not being divided by like with the indirect. Indirect, they're down bottom, right? The x is down bottom. But here they're up top or multiplied side by side. Same as up top, really, when you think about it, multiplying up top or on the side. So yeah, it's joint variation varying with two variables or more variables possible. We say z varies jointly as x and y. Like I said, you could also say z varies directly as x and y. So z is varying with these guys. Again, you have your constant of variation. So note that this equation, just like always, we could resolve it for k if we want to. To do that, you divide by xy and you get z over xy. Okay, so that's joint variation. Now, joint variation, though, is really just a special case of combined variation. What is combined variation? Combined variation is when you have just more than one variation together, right? So you have, instead of just one variable affecting z or whatever's on the left of the equation, you might have multiple variables. So let's look at combined variation here. So we could actually combine any multiple of direct and inverse variations, and in one sentence, if it's in sentence, it can be translated to an equation. So we say, for example, z could vary directly as a, b, c, d. And that just means a, b, c, d go up top. And inversely as e, f, g. That means the e, f, g go on the bottom. And I just randomly chose 4 and 3, but this could be any number of variables up top, any number of variables on the bottom. And then the constant integration out to the side, right? Multiplied together. Now you see the reasoning for how I labeled the inverse variation this way with the k on the side, right? But if you wanted to really, you could actually just rewrite this as the k up top as well. I just separated it so you can see a little bit more of a distinction between the constant and the variables. Again, reiterating, I said this earlier, but why is this a constant? Constant because it doesn't change once you figure it out. Whereas when you're solving these variation questions, like z is going to change, right? Depending on what the a, b, c, d, e, f, g are. And similarly, a, b, c, d, e, f, g, those are not fixed values. There'll be different values depending on where you are. Just think about it like graphically. If you should draw the graph, those things would be, actually, it's hard to imagine because it's beyond 3 dimensions here if you have that many variables. But if you just think of it like a simple case, right? Back to the direct variation, with as x changes, y is also changing. These are allowed to be different values, but the k is always the same. Okay, so that's combined variation. Again, just like always, you could solve for k easily. How would I do that? Let's take this equation up top as the starting point. So if this is the starting point and I wanted to solve for k, how would I do that? Just do the opposite, right? Multiply by e, f, g and divide by a, b, c, d. So these guys would all cancel. And then that would be the same thing on this side. E, f, g in the top, a, b, c, d in the bottom. And you see, that's what you end up with, right? The z times e, f, g top, a, b, c, d on bottom. But when you in practice, when we solve these things, we're going to be given enough numbers that we can actually solve for the k. So all these other guys are just going to be numbers. A, B, C, D, E, F, G. Those are all going to be numbers when you solve for it, even the z. And then we'll just have to solve for that k. Okay, so recapping, I mentioned this at the very beginning, but really these are the simple steps for solving variation questions always. Number 1, we'll be told the relationship between the variables to write the equation. Use k as the constant of variation. Although even though I say that, there's really nothing sacred about using the k. It's just a convention. You could use a different letter if you really wanted to, like c for constant. Okay, number 2, we're given data points that allow us to solve for k. That just means you're going to be given the different variables here, which will allow you to figure out what k is, right? You'll be given different numbers to plug in, allowing us to figure out what k is. And once you figure out k, we're going to rewrite our equation, plug that k back in, rewrite the equation, and then we use that equation to figure out whatever is the one unknown variable. When you're given an equation, you can only solve it if you have one variable, right? If one equation, one variable. If you have more than one variable, then you could solve it, but you'd have a variable in the answer. So you wouldn't be able to reach a conclusive number. Okay, that's it, guys. That's it. That's all the theory for today. So we're gonna just track all the remaining questions now. Let's start with 3 and 4 in this video. And then I've got 1, 2, 3, 4, 5, 6 remaining. Those are all word problems. You know, I don't know. Depending on how much time, we might do those last remaining word problems in 1 or 2 videos, depending on how long it takes. But in this video, let's just do 3 and 4. This is just talking straight about joint and combined probability. Starting with number 3. It says J is jointly proportional to G and V. And this is, you know, with these capital letters, it makes me kind of think of physics. You see a lot of these kind of equations, physics, right? And maybe this is like joules I don't know, I'm really bad at physics, actually. I only took 1 physics class, which is ironic. It was kind of counterintuitive, right? You think that someone who's learned a lot of math would have known physics, but I only took 1 physics class way back in high school. So sorry, not super familiar. But J sounds like maybe joules, gravity, velocity or something? I don't know. Anyways, J is jointly proportional to GV. That means G times V, and there's a constant in the front K, right? So that's the equation, we're told. And we're also told values to plug in, like always, to solve for K, right? We're going to have to solve for K. What are the values we're given? We're given that J is the square root of 3. Okay, nice ugly number. G is the square root of 2, and V is the square root of 8. Okay, that's kind of weird choices, but okay. And then we're going to solve for K, right? With pretty straightforward algebra from here, because we have just numbers. Okay, little things going on here, though. Square root of 2 is square root of 2, but square root of 8, okay, 8 on the side note is 2 times 2 times 2, right? Or 2 to the third. So anytime you have a pair, they can escape the jail of the square root symbol. So this 8, 2, let me write like this. If it's I have a pair, the 2 can escape, and leaving me with just a 2 outside, and then this last guy is stuck inside. He doesn't have a partner to escape the jail. So it's 2 times 2 root 2, right? Okay, but now you notice that there's a pair of root 2's, and if I multiply them together, then they can combine forces and escape the jail of the square root. So this is K times 2 times another 2. This, let me color coordinate here, actually, so you can see where each 2 came from. Let's use red. Okay, so these 2 square root of 2's combined to get a 2, right? And then this red 2 just carried down. So I have K times 2 times 2, and that's equal to the square root of 3. 2 times 2, of course, is just 4. And I like to have the number in front of the variable. That's the standard way of writing these things. So 4K equal to the square root of 3. Now to solve for K, you divide by 4 on both sides, and you get the square root of 3 over 4. Okay, nice ugly number again. K is square root of 3 over 4. Let's go back to our original equation then. And right now our new equation. So J is equal to the square root of 3 over 4 times G times V. All right, so now I have my constant of variation integrated into my equation, and I have to now solve for whatever is missing. Let's see what we're given. Okay, it's asking what is G, so that's the thing we're going to solve for, when J is root 6 and V is 8. So J is root 6, that's root 3 over 4, and we're solving for G, so G stays G, and V is 8. That's right, parentheses, so we know we're multiplying. Okay, so let's combine these guys first on the right-hand side. That's going to be square root of 6 equals to 8 on the top, 4 on the bottom. That is going to cancel, give me a 2 left over in the top. So I have 2 root 3 times G. Yeah, 2 root 3 times G. Okay, now I'm going to divide both sides by 2 root 3. So I get G is equal to square root of 6 over 2 square root of 3. But here is where you notice that there should be a little cancellation, because why? Square root of 6 is really a square root of 2 square root of 3, right? And just note, side note, these got to be positive numbers for us to be able to take square roots of them. Okay, so the square root 3 just cancel each other out. So I've got g is equal to 2 square rooted over 2. Root 2 over 2. That's g. Okay, and that was question number 3. There's the answer. All right, let's do the next one. Yeah, this section is, most of the time when you have a chapter, I feel like the easy section is up front, and then I kind of was expecting that. I told you guys that, I think, but then ended up kind of taking us long doing that first section, quadratic one. Unexpectedly, this last section is looking like possibly the easiest of all. But then again, we have word problems coming up, so we'll see. Okay, z is directly proportional to the cube root of u. Okay, what does that mean? Z is directly proportional means, okay, here's my constant first. It always goes off to the side. Directly proportional means the cube root of u should be out to the front. Okay. Inversely proportional to the square of v. So that means it's over v squared. Okay, so just to make sure that you guys are comfortable with my writing here, I'm writing my v's like this little tick thing. I'm trying to make them a little sharper. And then my u is more curly, and it's got the, what do you call it, tail coming down to the bottom. Okay, just to make sure you guys know what I'm writing, because sometimes my v's and u's look kind of similar. Okay, so this is the original equation based on this first sentence right here. Yeah, all the way up to here. Okay, wrote the equation. Second step now is to solve for our k variable, or not variable, sorry, the constant. So how are we going to do that? We're going to input the values that were given, plug them in, right? We're given z is 7, we're given u is 27, which is nice because we can take a cube root of it. Given v is 2. Did I say u or v? U is 27. Okay, so plug those in, and then we'll be able to solve for k, right? So let's do that. I forget what colors I've been using. Let's just use red. So z is 7. K is what we're trying to figure out. U is 27, and v is 2. And then it's being squared, right? Okay, so cube root of 27, that's just 3. And 2 squared is just 4. So it's 3 over 4 times k. And then how do I get rid of that fraction? Multiply it by the reciprocal on the other side, right? So multiply by 4/3. 4's cancel, 3's cancel. And this is 7 times 4, which is 28 over 3. And that is k. So k is this nice ugly number again. 28 over 3. Did I multiply that right? Yeah. Okay, so now that I have k, what do we do? What do we do, guys? Look at our original equation, and we just insert whatever k was, right? So z is... Okay, here's another trick, guys. So when you see 28 over 3, and, it's within some fraction like this, not really a trick, but this fraction, whatever's top stays up top, whatever's in the bottom goes in the bottom. That's just what's going to happen. We talked about, we kind of reviewed the rules of multiplication of fractions or division of fractions a little earlier. If you take your time and do it, you'll see that's just what's going to happen, right? 28 is going to stay up top, 3 is going to come down to the bottom. Okay, so now last step is to solve for whatever is being asked to solve for. And what are we asked to solve for? What is asked to solve for? What is z? Which is nice because z is already by itself, right? So it's asking what is z, and it's telling us the other guys. So the parts that we're told we're going to plug in. Just make sure there's a distinction there. So z is 28 over 3. Okay, actually, you know what? Let me leave it the same format so I don't confuse anybody. And this is the cube root of whatever u is. What is u? -8. And then v squared. What is v? -5. Make sure you have that in parentheses before it's squared. Okay, this is kind of nice because what's the cube root of -8? Well, 8 is a perfect cube number. It's 2 times 2 times 2. Because it's negative, it will be negative. -2 times -2 times -2. And you're allowed to take negatives because it's a cube root, not a square root, right? It's possible to get negatives because you have an odd number of what do you call factors? things that are within the root. Okay, so that's going to be -2, yeah? Cube root of -8. And the bottom is 3. -5 squared is going to be positive 25. At this point, I'm looking for anything that I could possibly cancel, but 28 doesn't have any factors of 3 or 5. It's 28 is really just 4 times 7, right? So this I've got 2's and 7 as 7's as factors. The bottom I have 3's and 5's, so there's nothing that's matching up. So it's looking like it's just gonna be what it is. It's gonna be whatever the result of multiplying that is. 28 times 2 is 56. Don't forget the negative sign from this -2. 3 times 25 is 75, like 3/4, right? And so there it is. Z is -56 over 75. Again, a nice ugly number. But that is it. That is it. It's really not so bad, right? Really not so bad. I don't think so. I hope you feel the same. Okay. Ooh, that's kind of satisfying. I'm going to color out of the lines just a little. Okay, guys. I'll see you in the next video. Have a good time.